Dive into adding and subtracting rational expressions. Earlier, what you guys have been doing in 4.1 has been multiplying and dividing, and you were required to fully factor all your expressions to be able to cancel and simplify the given problem, whether it was multiplying or dividing. So now we're going to go over to 4.2 and now do adding and subtracting. Okay, so the requirement of factoring still carries on with this concept, but there's going to be an additional one where you guys have to remember that when adding and subtracting fractions, you have to obtain common denominators. Okay, so just like when you guys were doing in elementary school with introduction of adding and subtracting fractions, the bottom numbers had to be the same. The same thing applies to rational expressions. Okay, so we're going to start off quite simple, and these problems are meant to provide you guys examples so that you are able to do the assignment. So we're going to start off here with number 1. So here is an example of fractions that are being subtracted, but notice that the denominators 6 and 9 are not identical. Okay, now with this one, since it's pretty simplified, there's nothing to factor. Okay, but what you want to do is obtain that these end up being the same. So what you're going to do is look for the least common multiple to make the denominators common. What is the least common multiple of 6 and 9? So if you think of all the multiples of 6, 6, 12, 18, 24, and so forth, and you think of the multiples of 9, 18, 27, what's the least common multiple? 18, right? So what your goal is to make them both 18. Okay, so again, just least common multiples, you're literally 6 times 1, 6 times 2, 6 times 3, if I can remember to multiply, and so forth, and then 9 times 1, 9 times 2, 9 times 3. So you're looking for the least common multiple. That's what you're looking to do. So we need to force these to become 18. So I need to multiply 6 by what to get 18? 3. And whatever I do to the denominator, I've got to do it to the numerator. Okay, the same thing with the next one. What are we going to multiply 9 by? 2. So let me make this a little bit bigger so that it's easier to see. All right, there we go. We need to multiply, 9 by 2. So I'm going to multiply 2. So make sure you do it to both top and bottom. So in this case, 3 times 5x will be 15x over 18. 7x times 2, and I put a plus, I meant minus. 7x times 2 would be 14x over 18. And now that we have the denominators being identical, we can go ahead and combine. Now what I want you guys to notice is when you are combining fractions, you are combining only the numerator values. The denominator value that is common just comes over and carries over for your final answer. Okay, so you're not subtracting or adding when it comes to common denominators, it just carries over. Just focus on the numerators. Okay, so you'll have examples like number 2 where your denominators are already the same. So once they're already the same, all you're going to do is combine your like terms. Okay, so combine like terms. So I'm going to give you a second to do that on your own. And then of course put it over the common denominator of 7x. So calling out on someone, let's see, Hannah, can you tell me what you got for your numerator? My bad. 14x plus 8. Very good. Okay. All right. Now let's go on to let's do one more. Number 3. Go on to number 3. Now, sometimes you're going to have problems like this that have denominator values that have a variable as well. So if you look at number 1, it only had a number, 6 and 9. Number 3, you have a number and a variable. So what you're going to do is you're going to look first at the coefficients, 6 and 1, and determine what the least common multiple would be between 6 and 1. And what is that? It's going to be 6, right? So we're going to convert, as far as the coefficients go, the 1 becomes a 6 by multiplying top and bottom by 6. Then you look at the variables. It does both have 1x, but it's not always going to be the case, okay? So if there is more than one x in one than the other, you've got to even those out, all right? But in this case, once we multiplied by 6 on this fraction, top and bottom, we get the 6x that we needed. So we end up with 5 over 6x, that didn't have to change, plus 36 over 6x, and so now we can combine, okay? So make it a goal always to get those fractions to be the same. Another example would be, we'll skip number 4 and 5 if you would go with me to number 6. Sometimes you are going to add and subtract where a whole number is involved. So the reminder with regards to whole numbers is that there is an invisible 1 underneath that whole number, okay? So as you can see right now, x minus 9 and 1 are not common denominators. I need you guys to treat factors as a complete number in of itself. So imagine it having parentheses around it. The x doesn't stand alone, the minus 9 doesn't stand alone. X minus 9 works as a unit, okay? So when you end up with situations such as this where the denominators are not the same and I need them to be the same, what you're going to do to force this one to look like this is multiply it by a factor. So also know that you are not only multiplying by numbers and merely like an x or something like that, you can multiply top and bottom by a factor, which in this case will force our rationals to have common denominators. So the first one, 2x plus 3 over x minus 9, that one doesn't change. But this one over here, notice that we're going to have to distribute our 2 to the x minus 9. So it's going to become 2x minus 18 over the denominator that we needed, which was x minus 9. And now that it's the same, you can combine all the upstairs values. Combine the like terms. So 2x and 2x becomes 4x. 3 minus 18 becomes negative 15. And we get the green light. Okay? Are there any questions on number 6? Or on any of the previous problems? Is everybody okay? It's pretty simple so far. Straightforward. Okay. Stuff like number 7 can happen where it looks very, very similar. Okay? We did something similar before with regards to this problem. So x minus 6 and 6 minus x are not the same. What can we do to force them to be the same? Does anybody remember or recall what we did before? What can we do? Because right now, here's your hint. X is positive. Here, x is not positive. 6 here is negative. 6 here is positive. We need them both to be the same. Go ahead.
Swap the signs of both top and bottom.
So you're talking about for this one?
For 2 over 6 minus x.
Okay, so when you say swap the signs, what should I write?
Multiply -1.
Okay, so you are saying multiply both top and bottom by -1, and that is absolutely okay. It forces her bottom terms to get the signs that we need. So the 2x plus 7 is going to stay, but 2 times -1 becomes -2, But if you multiply negative 1 times 6 and negative 1 times x, we are going to get the x minus 6 that we needed. So x minus 6. Excellent. Okay. Multiplying top and bottom by negative 1 is in essence multiplying by a positive 1. You're multiplying by a number to force it to change. All right, so very good, Gray. So 2x plus 7 minus 2 is going to be 2x plus 5 over the x minus 6. Okay?
Is it even or odd day?
Say it again.
Is it an even or odd day?
Today is odd day. All right, here we go. So here is an example that's similar to number 1, but we have factors. Okay, so going back to number 1, I want you guys to notice your denominator was 6 and a 9. They were distinct denominators. So we multiplied them by 3's and 2's to force it to become 18, okay? We also will have distinct factors, okay? So in this particular case, we have an x minus 6 and an x plus 5. They're completely different. And remember, I told you to treat x minus 6 as a unit. It can't be split up. The same thing with x plus 5. So what we do to force these to be the same is we're going to multiply top and bottom by the factor of the other rational. So I'm going to multiply x minus 6 by x plus 5 upstairs and downstairs, so that I'm telling myself I'm actually multiplying by 1, and I'm going to multiply this one by x minus 6 top and bottom. And when I do so, now I have common denominators, because the denominator over here is going to be x plus 5, x minus 6, and the denominator over here is going to be x plus 5, x minus 6. So I'm forcing the hand, okay? Now what I want you guys to do though, and you'll make a note here, only multiply NUM for numerator. Well, I guess I could fit it, numerator, okay? I want you to only multiply out the numerator. Do not multiply the denominator. And you'll see why eventually, okay? I don't know if this particular problem is the first time I'm working it out with you guys, but you'll see eventually what I mean by that. So we need to multiply x plus 5 times 7x plus 3, okay? Now some people use FOIL, some people use the box method, so I'm going to do both box method and FOIL so that you guys know what I mean in coming problems, okay? So for this particular problem, I'm going to use the box method, and if I come over here, I think I might have enough space. I'm going to write x plus 5, or yeah, x and a positive 5 I should write. Let me take the plus 5 away. So x plus 5 is going to be horizontal, and I'm going to put x and 7x and the 3 like this, okay? So the x, what's that?
Why are you doing that?
Some people, in all my classes, some people are foiling, like this times this, this times this, this times this, this times this, and some people are using the box method.
Oh.
So I'm just doing the box method on this one, and I'll FOIL on another one to show both examples to satisfy both people. Okay, so if the box method is not your thing, you don't have to write this out. If you do it by distribution, for those of you that want to do it that way. All right, so here we go. So I'm going to do that. All right, so x plus 5 is upstairs, 7x plus 3 is over here, so 7x times x is 7x squared, 7x times 5 is 35x, 3 times x is 3x, 3 times 5 is 15. Okay, we always know with box method that the diagonals are like terms, so my answer for the numerator here is going to be 7x squared, 35 and 3x makes 38x, and 15. Okay. 7x squared plus 38x plus 15. Okay. Then I'm going to put it over x plus 5, x minus 6, plus, and this one's pretty straightforward, so the 3 times the x minus 6 ends up being 3x minus 18 over x plus 5, x minus 6. Okay. All right, so far are we okay? All right. Sorry we don't have as much space here. I might have to get another piece of paper to show my work more clearly. Okay. Let me do this so that you guys can see what I'm writing. There's also space back here if you have to tell yourself to flip over if you run out of space. If you write big like me, so I apologize. All right, so we're going to combine our like terms. So 7x squared, there's no others, so we're going to have 7x squared. 38 plus 3 gives me a positive 41x, and then 15 minus 18 gives me a negative 3. Then I have x plus 5 and x minus 6. Okay. So I just combine the like terms. Okay. And watch your signs, especially if this is a minus, please watch your signs. So 7x squared, 38 plus 3, 15 plus negative 18. Now, here is where you would feel that, okay, I'm done, but here's what I need you guys to always do, okay? You guys need to check to see if this can factor, all right? Always check to see if this can factor, because if it can, you need to factor it so that it will cancel out with any factors in the denominator. In this particular problem, it's not going to factor, okay? How do I know this? Well, you guys have a trinomial, all right? When a is not 1, you multiply 7 times negative 3, and you get negative 21. And notice what happens. If I'm looking for two numbers that multiply to be negative 21, that at the same time add to be 41, there aren't any possibilities, okay? 1 times 21 is 21, 3 times 7 is 21. There aren't any other numbers that multiply to be 21. So this cannot be factored, so this is your final answer, okay? But always check to see if the numerator can factor, okay? So as far as this particular problem is done, we stop. We're done. That's your final answer, okay? But sometimes what's going to happen is that this factors out, and one of its factors ends up being one of these. You will cancel just like you did in 4.1. Does that make sense? Okay? All right. So that's how you do number 8. I'll let you guys, okay, and I guess we can write here, it can't, okay. For this particular problem, it couldn't factor. All right, as you finish copying that one, let me look at the next problem. Let us do the AC method. You multiply the 7 times the negative 3, because A is not 1. Remember when you have a trinomial?
Yeah, but you don't need to do that. So, you just like wrote it to like remind you.
Yeah, yeah, exactly. Yeah. Let's go over to the next side. Let's go to number 13. We'll do number 13 and number 15, and then that will be it. Okay? So let's do number 13. And I'll put the answers to the rest of these, and also if you want them immediately, there's a what do you call, QR code at the bottom you could scan and get all of it worked out, okay? Okay, so you are going to get problems that look like this. Notice that the denominators are obviously not the same, but what you want to make the connection is that the first denominator, you should be like, oh, I can factor that, okay? So notice it's a trinomial. The good news that we love to see is that when a is 1, we're happy about that because it's so much easier to factor when a is 1. So what two numbers multiply to be 24 that add to be negative 10? What times what multiplies to 24 that adds to be negative 10?
Negative 12, positive 2.
Okay, so it didn't work. So it worked for this part, right? But it's not working. Gray, you happen?
-6, -4.
-6, -4 does work. All right. So keep trying your combinations until it satisfies both, okay? And so we've got that. Now, we look at this now that it's factored and we realize, well, they're almost the same, right? So what can we do to make these the same? Natalie, do you have an idea? What can we do to make them the same? The first one's x minus 6, x minus 4, and the second one is x minus 6. Why are they not the same?
Because the second one is not x minus 4.
Very good. So with that answer, you're like, well, I want the second one to have an x minus 4, so do it to top and bottom. Okay? So go by that discussion, that inner talk that you guys are having. You're like, okay, it's not the same. What do I want? How can I force it to be the same? All right? Now remember what I told you. Don't ever multiply out the denominators. You only are concerned with upstairs, okay? Only are concerned with upstairs. So the 1 is not doing anything, so I'm going to put a 1, and then I need to multiply. I'm going to do this. I'm going to put this as a plus, and I'm going to move the minus up like this, okay? I'm going to make it a plus minus because it's easier to not make the mistake. So negative 2x times x is negative 2x squared. Negative 2x times negative 4 is a positive 8. The denominators are the same, so I'm just going to do one of them. I'm not going to write it twice. X minus 6, x minus 4. Okay? So do your little arrows if you think you're going to forget to distribute. Okay? Then we're going to combine our terms. Negative 2x squared. I put it in order from highest to lowest power. Plus 9 over x minus 6, x minus 4. Okay. Go ahead. Did I make a mistake?
Wouldn't -2x times -4?
You are absolutely right. Thank you. I did make a mistake. Thank you, thank you, thank you. Very good. So I modeled a very good mistake. Do not do what Hanlon did. So negative 2x times x is negative 2x squared. Negative 2x times negative 4 is positive 8x. Thank you for that, Gray. All right, so let me rewrite this in order. Negative 2x squared, positive 8x, and then positive 1. All right, so again, you ask yourself, you look at that numerator and make sure if it factors, okay? Check to see if factors. And I'm very disillusioned that so far we don't have one that has. But again, this one is where a is not 1, so you multiply negative 2 times 1. And so you ask yourself what times what is negative 2 that at the same time adds to be 8. Are we able to find that combination? We can't. So that's your final answer. You're done. When I created this worksheet, it automatically generates problems. So unfortunately, it didn't generate one that I would find that it cancels. So we will see on the last one. But any questions thus far? Ready for the last one? All right, last one coming up. All right, number 15. So go ahead and take a moment, and I want you to factor that first denominator, and then we'll go on together. And if you need the reminders, you can put little symbols underneath those numbers to remind you the questions you're asking yourself. What two numbers multiply to be 12 that add to be 8? Okay. All right. So Kendall, can you give me the factors when you're ready for x squared plus 8x plus 12?
6 and 2.
6 and 2. All right. So x plus 6, x plus 2. Okay. All right, let's see now. So we look at our denominators, and by the way, I'm one to make it a habit. Some people like to leave it as subtraction, but honestly, I find that students that change the subtraction to a plus and just move the negative in front the next number make less mistakes when they are distributing. So just a suggestion, but you do what's most comfortable for you, okay? All right, so our denominator for the first one is x plus 6 and x plus 2, and the other one is x plus 2. So I'm going to ask, let's see, Brandon, what do you suggest we do to make these two denominators the same?
Multiply x plus 6.
All right, multiply x plus 6. So whatever it is that we're missing, just multiply top and bottom. And then we just do the typical arithmetic. So first one, we didn't do anything. 7x plus 5. Negative 7 times x is negative 7x. Negative 7 times 6 is negative 42. And then I'm just going to put it over our common denominator. So, not that it matters, but I'll be consistent. We'll combine our like terms. Our x's are disappearing, and then our numerator just has a constant, and we are done. Okay. Nothing can be factored. It's as simple as it can get, and that would be our final answer.